Hey everyone, and welcome back. We are discussing reading files in Java today. So we're going to discuss how we can bring data into our Java program, and this video is going to cover specifically reading files using Scanner and BufferedReader, two built-in Java files. If you want to learn more about them, like the different methods that they contain or different ways to overload the constructor, you can go ahead and check out the Java Oracle documentation. I may pull that up in a little bit. We're also going to discuss understanding file paths, as well as ways to handle missing files gracefully. We are not going to be going too deep into exception handling outside of like the basics for handling missing files, but we will cover it in a future video. So in the 5th video in this series, so in 2 videos time, we will get a little bit deeper into that. So Python Tutor actually doesn't handle file reading particularly nicely, and so we're going to do all of this in my Sublime text editor instead. Let's start with our basic main class, and we're going to start a discussion around the file object. In order to access the file class in Java, we do have to add an import, just like we would do if we were accessing like the random class that we've done in the past. And then we can make our main class, or our main method in here, and let's make a file. So let's do file is equal to a new file, text.txt. So we include that extension in this. Now, what this is going to give us access to is information about the file, but it doesn't actually let us read the file directly. The file object is really just the string path and being able to determine if that file exists or not. So for example, if I do a print of the file .getName, or I do a file .exists, we will see that this text file, text.txt, if we look over here, does not exist. Now the way it works is that since my main.java is right here, and I am looking for a text.txt, it is going to look effectively in my file explorer. Like if I open up my Finder and I look at my file explorer right here, it's going to just look for it on the same level as my main.java file. If I want to look, let's say, in data files instead, there's nothing in there right now, but if I wanted to look in data files instead, I would have to actually say, go into the data files folder and look for the text file there. So it's important that we understand where our text file or our data files are in relation to our main.java file. All right, let's give this a quick run. I'm just going to do it through my terminal here. I'm going to go to the desktop directory. I will compile my main.java file, and I will run it. And what we will see is that I am printing out the name of the file, which is indeed text.txt, and false. Right there, it's false. Now, let's go and put a text file inside here instead. Text editor. Oops, we can just do it actually through here. This is the text.txt file. I'll go ahead and save this as text.txt, and I'm going to save it inside that data files folder. So now when I come back here, this still will not exist, right? I don't actually need to recompile the code because I didn't change the code. I only changed a text file, and text files are not compiled. However, if I now want to do data.files/txt and I save this, I will need to compile it. And then I can try again, and what I will see is it does indeed find that text file, text.txt, and it's true. I will change this one more time to show what the object prints out if we just put the word file there. So like the object itself is getting printed out, and what you'll see is it gives you the full path, whatever was entered is what you get out, as opposed to getName, which just gives you the name of the file. So this is how we can access a file and get some information about that file. Now, as I said, this doesn't actually open the file to get the contents out. So what is going to open that file? Well, we have 2 different options for opening actual data files. And the first one that we'll discuss is going to be Scanner. Now, if you're new to using Scanner, this one also needs to be imported. java.util.scanner. And before we jump into how to use this file, I'll just comment it out with Scanner. I'm just going to show off Scanner because some of us may have used it in a previous course, getting input from the user. Some of us may not have. So if you had, you would have seen something like this. But I am going to show you something else, which is that Scanner can read strings directly. This is a string inside the scanner. And the way Scanner works is you can read by line or by token, token being space delimited words. And we can go word by word or line by line. This is only one line, so I am going to focus on tokens for right now. But again, go check out the documentation on Oracle to see how to use this in different ways. The way Scanner works is it will scan along the line looking for the space that delimits a token. It stops and returns the word it found, and it holds its place right here where that orange line is. And then when you call on finding the next word, it will do it again. So it does exactly what it says. It scans our string, finds the tokens, and returns them. Scanner gives us access to stuff like has next. Has next will determine whether or not there is another token or word to scan. As long as there is, we can go ahead and grab it, scan.next, and this will grab that word and print it out. Let's go ahead and run this code. There we go, and we can see that the string that we passed in does get read in line by line by line, which also means if I were to do something like put this in, this string, just as I did for file, there was a reason for this, I'm not going to get the internals of the file. I'm still just going to get the string. So that's not enough to get our scanner working the way we want it to. Instead, we need to pass in the file. So we can pass the file directly into Scanner. Scanner does have many different constructors. It can take in the system.in reader. It can take in a file. It can take in a string. Those are all overloaded constructors that you can see in the Oracle documentation. Now what we'll see happens when I try to compile it is my code breaks. Let me just move this up a little. There we go. Now, while we're going to cover exceptions in a future video, for right now, we're going to understand that we have to figure out what we would do if we tried to open this file, because previously we weren't opening it. If we try to open this file and it doesn't exist. We did see a case where .exists came back as false. Using an if statement to check it first does not cut it. Java does not think you will remember to put that if statement to ensure it exists first. So instead, Java has a very special way of handling these situations. I'm going to basically just write them out for right now. And when we do exceptions and have a deeper conversation with exceptions in video 5, you'll learn a bit more about it. So we have two different ways to ensure that Java is comfortable with our ability to handle this situation. The first one is a try like this. And then we put a catch here, and we catch that file not, found exception. And we can do something like print out the stack trace or say file was not found. There we go. Now our code will compile. Oh, it will compile when we bring this exception in. That comes from this library as well, that file.io library. I'm just going to change this to a star so I don't have to worry about bringing in each individual sort of object that I want to use from the IO library. Let's go ahead and make this slightly bigger. Now our code will run using Scanner, and we'll be able to read in our whole file. Let's go ahead and see that working. There we go. This is the test.txt file. So this actually came in from this file. If instead I tried to do it like this, and a reminder that text.txt does not exist, we try to compile. The file wasn't found because it doesn't exist. So Java tried to find the file. It tried to open and find the file. It didn't work, so it caught this exception that was thrown by the constructor. Again, we'll talk about that more later. And it ran in this catch block instead of inside the try block. Okay, there's one issue here, which is in complicated programs, if we don't say Scanner, let go of this file, the Scanner doesn't. It holds onto that resource, and then nobody else can use it. So it's really important that at the end we close our Scanner resource off. So this will release the file from Scanner's grip and allow other parts of the program to use it. This doesn't really make a big difference in our size programs, but it is a good programming practice and a required one, given that in the future, this might be something that you need to do. Now, the other thing that we can do here, instead, if we don't want to have to always remember to do this, is we can actually use something called try with resources. And try with resources just looks like this, where inside round brackets, we put our scanner declaration. We put the piece of code that might explode and that is going to hold on to our resource, hold on to that file. And now by default, this actually closes the file off for us. So that's incredibly helpful. And I'll just show you that this also runs as expected. Let me just recompile that and run it. And we'll see it ran again. And if I put data files back in so that it can find the file, we'll see that it does. Perfect. So now I will also say that I have another file that I've created, a data.txt file with a little bit more information in it that I want to use just for this next example. There we go. It's a little bit longer, we can see. And we can use it for this next example because it is a little bit longer. And this is so silly. We're reading in word by word, and it's, you know, a lot being printed out like this. This is our token-based reading. Now, while Scanner can do line-based reading, instead, I'm going to show you a different tool. You can use Scanner by just saying has next line and next line. Okay, that would work 100%. But I do want to show you a different option, which isn't Scanner. It is called BufferedReader. Now, BufferedReader is another way to read in files, but it actually doesn't take in a file like this. It takes in something called a reader. So we have to declare a new file reader, and here we can pass in this txt. So this file reader will actually open the file for us, named data.txt. Then BufferedReader will read and effectively do similar work as the stream from Scanner did to read in the contents of the file. So now this is our BufferedReader. I'll put BF here. The difference is BufferedReader can throw, oh no, and that's fine. There's no difference. So now we can change this. We can say, we have a couple of changes we have to make here. So now the thing is, BufferedReader doesn't have this Boolean has next line. It's a little bit more archaic. We just have a read line. We can read in the line into our program and then go from there. Once we read in the line, if we are at the end of the file, that line variable is actually null. So while it's not null, there's still things to read. And we can do stuff like print out that line. The catch is we can't forget to read in the next line at the bottom of this loop. If we forget to read in this line at the bottom of the loop, we get stuck in an infinite loop, and that's no good. All right, let's go ahead and compile this. I see. We run into another error. We can see right here a couple different things. Unreported exception must be caught or declared to be thrown. And what we can see here is that the line is this one right here. Again, we're going to talk more about these exceptions in a different video. But what I will say for right now is, you know how like all apples are fruits, but not all fruits are apples? Hear that line in your head and be like, yeah, that makes sense. All file not found exceptions are IO exceptions. Not all IO exceptions are file not found exceptions. So if I told you to catch a piece of fruit and I threw an apple at you, you would catch it. Even if I didn't say apple, I just said fruit. If I was like, here, catch this, and catch all the fruit I throw at you, and I threw you an apple, you'd catch it. You'd also catch a banana, you'd catch an orange. But if I told you to catch apples and I threw a banana at you, you'd ignore it because it's a banana, it's not an apple. Consider file not found exception to be an apple. Consider IO exception to be a piece of fruit. I'm going to go ahead and change this to say IO exception. And now I'm telling my code to catch IO exceptions. And thankfully, since this is a file not found exception as well, it's an apple, which is a type of IO exception, this covers both scenarios. So now when I compile my code, it will compile successfully and I can run it. There we go. And we can see each line coming in on its own line. Very helpful. Once we've done this, we can do a lot of different things with our code here. For example, we can count the number of lines. We can also count the number of words on the line. So for example, imagine we want to figure out how many words were on the line. 1, 2, 3, 4, 5, 6, 7, 8. So by default, we're going to say that the number of words on the line is basically anything separated by a space. How are we going to do this? Well, we can actually use a string method known as split, which we haven't seen before. And we can split our line on a delimiter. And in this scenario, we want to split on the delimiter single space. You can split on lots of different things, but for right now, we are going to pick single space. Now I will have an array of each of these words, which directly tells me the number of words on the line is tokens.length. There we go. So now I can go ahead and clear this. I can run this. And there we go. We can see the number of lines on each word, the number of words, pardon me, on each line. 1, 2, 3, 4, 5, 6, 7. The number of words on the line is 7. And we did that for each and every line. This is just a starting place. You could do lots of other things. You could isolate the number. You could count the average number of words per line. You can count the punctuation per line. There's a lot of great challenges that you can start to work through given this level of understanding on string manipulation and lines and file handling. So we've covered file and path representation. We've covered Scanner and how we can use it both to read in files, but also use it to process an individual line. We've also discussed BufferedReader and how we can use it to sort of read in everything bulk lines and then maybe even use some of our string methods and core method functionality to manipulate those lines and solve some problems. We also very briefly discussed the try with resources and the importance of using some manner of closing our files. In our next video, we're actually going to flip this around and we're going to talk about writing data back to files. But starting now, you should be ready to go and try and do some file manipulation and some of the basic problem-solving challenges that I've outlined already. If you're looking for another slightly harder challenge, consider counting the number of times that the word line appears in the file. Something like that. That's always a good one. All right, with that, I'll say thanks so much, and I'll see you in the next video. Bye.